All right, let's talk about something that could totally change the way we eat. I'm talking about a scientific breakthrough that solves a problem that's been around for, well, for thousands of years.
I mean, it's a simple question, right? But the answer is pretty much universal. You're enjoying a fantastic piece of fish, everything's perfect, and then, bam, that split second of panic when you feel that tiny, sharp little bone. We've all been there, doing that careful little dance trying to deal with it. It's the worst. This has been the trade-off forever. You want that amazing flavor, you risk the bones. It's a real worry, especially if you've got kids or you're serving it to older family members. It kind of turns a delicious meal into a high-risk activity. But what if we could just get rid of that risk completely? Well, this is where it gets really cool. Science has found a way. So let's get into the good stuff and see how researchers basically found the off switch for fish bones. So the key to this whole thing? It comes down to one single gene called runx2b. Seriously, you can think of it like a line of code in the fish's DNA. This one tiny instruction is the master blueprint that tells the fish's body, hey, go ahead and build all those tiny, super annoying bones. This entire revolution hinges on targeting that one specific gene. And the process for how they do it is actually pretty amazing. They use a technology you've probably heard of called CRISPR. It acts like a pair of molecular scissors. They go into a fertilized fish egg, they find that runx2b gene, the bone blueprint, and they just snip. They disable it. That first fish is called the F0 generation. Then they breed that fish. And its babies, the next generation, they are born completely 100% free of those pesky little bones. It's incredible. Now, this is a really important point to make. When people hear this stuff, their minds often jump to GMO. But this is different. In a lot of GMOs, you're adding a foreign gene from another species. Here, they're not adding anything new at all. They're just switching off a gene the fish already has. It's more of an internal modification. Nothing foreign is introduced. And of course, something this big doesn't just happen overnight. This breakthrough is the result of years and years of dedicated work from some brilliant teams, led by people like Professor Gao Zexa and academician Gui Jianfeng. And they didn't just jump straight to carp. They first tested and proved their method on other fish, making sure it all worked, before perfecting the technique in the grass carp, which so many people love to eat. So, the science solved the bone problem. Awesome. But that brings us to the next big question, probably the one you're wondering right now. What is this new boneless fish actually like? Did they have to sacrifice taste or texture to get rid of the bones? Well, get this. The descriptions from the people who've tried it sound amazing. They say the texture is incredibly tender, almost like tofu, just melts in your mouth. And the flavor? Apparently, it's excellent, even comparable to a premium fish like sea bass. It sounds like they've created the best of both worlds. And this chart really tells the whole story. Tiny bones? Gone. But the taste, the nutritional value, even how fast the fish grows, all of it remains pretty much exactly the same. They literally just removed the one thing nobody liked and kept everything that people love about the fish. And that's really the ultimate takeaway, isn't it? The perfect result. You get all the flavor, all the good nutrition, with absolutely none of the hassle of those tiny bones. Okay, so the science works, the fish sounds delicious, but when can we actually buy it? Let's take a look at the journey from the lab to your dinner plate. But one way you know this is serious is by following the money. A huge agricultural company, Guangdong Haida Group, has reportedly invested 50 million yuan to buy this technology. 50 million. That tells you this is way, way past being just a cool science experiment. This is serious business. So what's the timeline looking like? The research part is done. Right now, it's in that crucial regulatory approval phase. If all goes well, the researchers are hoping we could see this boneless carp hitting the market in a big way around 2026. So, not too far off. And that final hurdle is a big one. The approval process, especially in China, is really rigorous. This boneless carp is being treated with the same strict guidelines as GMOs, which means it has to pass a whole battery of comprehensive safety and environmental reviews before it gets the green light for commercial farming. But it's important to remember this isn't happening in a vacuum. Other countries are already moving ahead with this kind of technology. Japan is already selling a gene-edited tilapia. The US and Argentina have approved other gene-edited animal products too. So there's a clear global trend towards accepting these kinds of food innovations. So let's just zoom out for a second and think about the big picture here. Assuming this gets approved and becomes common, what does a truly boneless fish actually mean for all of us? For cooks, for families, for our whole food culture? Well, the potential impact is revolutionary. First, the obvious one. It's so much safer for kids and the elderly. For chefs and home cooks, the prep time saved is just immense. But think bigger. This could streamline the entire fish processing industry, cutting costs and waste. It just fundamentally makes eating fish a more enjoyable, worry-free experience for everyone. And this is where it gets really exciting for anyone who loves to cook. Just imagine preparing those incredible traditional dishes, like a pickled vegetable fish or a fishbowl congee, with zero tedious deboning. Suddenly, these recipes become so much simpler. You can just work with the beautiful flesh and not worry about picking out a million tiny bones. So, there you have it. This innovation has solved a problem that has plagued fish eaters for millennia. It's a powerful reminder of how targeted science can transform our daily lives, which leaves us with one last fascinating question to think about. Now that the fishbone is solved, what everyday annoyance should science tackle next?